Hello everyone, I hope you are doing well. I welcome you all in this question series based on the first chapter, that is relation and function, and the second chapter, inverse trigonometry function. This question series is completely based on the unit first. Okay, so let's start our question series. The first question is the first question. Let A is here 1, 2, 3, 4, that is a finite set, and B is 1, 2, 3, 4, 5, 6. It is given. Two sets are there. Function is defined from set A to set B. How it defined like that? Okay. And they ask that for all x belongs to A, this function is defined. And they ask f is bijective 1, 1, onto or many 1. You need to tell. Okay. Here function is defined from set A to set B. Okay. And how it define f of x is equals to x plus 2. Function is defined x plus 2 for all x belongs to A. So, and they ask that is it bijective 1 1 onto or many 1. Okay. So first, as A is a finite set, so we can find all the elements corresponding to each element of A. F of 1, if input is 1, then the output will be 3. If input is 2, then the output is 4. If input is 3, then output is 5. If input is 4, then output will be 6. Okay. So here we can observe that these are the outputs. So it means that this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, and 6 is there. Okay. And function is defined from set A to set B. This one maps to 3, 2 maps to 4, 3 maps to 5, 4 maps to 6. Here we can clearly observe that this is a 1 1 function. This is a 1 1 function because different element of A have different images. But you can see range of f is the collection of all the outputs corresponding to set A. So outputs are 3, 4, 5 and 6. Okay, but it is not equal to the codomain. Okay, implies that f is not onto function. Okay, if f is not onto function, it implies that f is not bijective. So it means that which option is wrong? F is not onto, many one is not there, only 1 1 is there, bijective is not there because it is not onto, hence it is not 1 1, because for bijectiveness 1 1 plus onto both are required. Okay, so here the C option is correct. Okay, now the next question will be, so next question. So here what they ask, here, this is a question number 2. They are asking cos inverse cos of minus pi by 3. Okay, recall cos of minus theta is equal to the cos of theta. Okay, so according to this, cos of minus pi by 3 is cos of pi by 3. So it implies that cos inverse cos of pi by 3. Okay, cos of pi by 3 value is, cos of pi by 3 is 60. Okay, so it means that 1 by 2 we have. Okay, cos inverse 1 by 2. Okay, and it will be cos inverse cos of, so what we get here, or we can say here, we can see immediately, we can apply here pi by 3. Okay, as pi by 3 belongs to 0 comma pi. Okay, close 0 comma pi we can apply here also, close 0 comma pi. Okay, so this is our second question. I hope you understand. Why? Because cos of minus theta is cos of theta is here, we use this thing here, and then we can apply cos inverse cos of pi by 3. It will become pi by 3 because as pi by 3 is in between 0 to pi. Okay, it is its principal value. Okay, now the next question. Next question will be, yeah, next question is our assertion and reason question. Okay, it is an assertion reason. So let's start the question. This is question number 3. Set A is given -1, 1, 2, 3, and set B is given 1, 4, 9. Function is defined from A to B. Okay, how it defined? F of x equal to x square. Then f is a many-one function. Is it so? Okay, so let's check like that. -1, 1, 2, 3. Okay, and this is your A set, this is your B set, 1, 4, 9, and function maps to from here to here. Actually function is f of x equal to x square. Function is x square. Okay, if function is x square, then what we can say? -1 maps to 1, 1 maps to, they both maps to 1. Okay, and this 2 maps to 4, 3 maps to 9. Oh, clearly we can see that it is not a one function. Actually it is a many-one function, because two elements, because two elements maps to same element, maps to same element. That's why it is a many-one function. Okay, so it implies that A is correct. Okay, if A is correct, then D is wrong. Okay, now if x1 not equal to x2, actually it is x2. Okay, it is x2 here, it is not here. Okay, so wait, I'll do by black pen. The x2 is not here, actually x2 is here. Okay, so they are saying that actually in assertion, reason, x1 not equal to x2. If this thing is happening, if x1 not equal to x2, then f of x1 not equal to f of x2. Okay, so it means that they are different element and their images are also different. So it is a definition of it is a definition of 1 1. Okay, for every x1 x2 belongs to domain, then f is a 1 1, or else many 1. Obviously if this thing is not true, this thing means if x1 not equal to x2, okay, but f x1 equal to f of x2, then we can say it is a many 1 function, which is happen in the assertion. Okay, but here we can see it is clearly a definition of 1 1. So I think in my coding option A is true, because it gives proper reason for that one. Okay, now we have next one, we have second, third complete. Now fourth we have. Okay, the fourth one, what did it say? Fourth one is R is an equivalent solution. What they said? R is an equivalent solution. Let R is an equivalent solution on set A. Okay, they already given that R is an equivalent solution. Okay, and how R is defined? Like that R defined. Write the equivalence class of 0. Okay, as we know that here they are saying that A, it is already mentioned, set A is 0, 1, 2, 3, 4, 5. Okay, done. And relation R, how they define relation R? Relation R defined as it contain those ordered pair such that A minus B divide A minus B divisible by 2. Okay, now what we need to find, actually R is an equivalent solution. If R is an equivalent solution, then for each element we have equivalence class. So here we need to find actually class of 0 element. Okay, it representation, all three are the representation for the equivalence classes. Okay, how we can find equivalence class? Actually equivalence class is the collection of all those element of set A which is related to 0. Okay, and x belongs to A such that x minus 0 divisible by 2. Okay, and here x belongs to A, x is divisible by 2. So it means that how many elements? It means we need to collect those elements of A which is divisible by 2, that is 0, 2 and 4. So this is the class of 0 for the given relation and for the given set A. I hope you understand this question. Now, also one more thing is here. Wait, I'll generalize it. I will generalize this question as here what they are saying, not. Here they are saying that we have a relation A comma B, ordered pair A comma B, such that A related to B if and only if A minus B divisible by 2. Okay, and here A comma B, they are giving set A. It may possible in exam natural number will come, it may possible set of integer will come. Okay, and that means any finite set, any natural number set, a natural number set or integer set. Okay, so how we can deal if they change the question. Okay, if here in place of divisible by 2 it is given divisible by 4, then what we'll do? Okay, so clearly this relation guarantee equivalence relation on set A, natural number or integer. Okay, but after proving that it is an equivalence relation, we need to check how many equivalence classes are there. How many? Question is how many equivalence classes are there? So how many equivalence classes are there? If divisible by 2, then the class are 0 and class of 1. Only two equivalence classes are possible, class of 0 and class of 1. If we need to find the class of another element, then that, suppose we need to find the class of 2, then the class of 2 is same as that class of 0. Okay, why I am saying this thing? Listen, here we need to collect, I am taking on integer set x belong to z such that x related to 0. Okay, x related to 0. Now it means it is a collection of all those integer such that x minus 0 divisible by 2, or we can say directly x is divisible by 2. It means that this complete set is like a 2k where k belongs to integer. That means all even integers, all even integers, and hence if we find the class of 1, guaranteed will contain all odd integers, all odd integers. Okay, so if I am going to find the class of 2, then class of 2 is same as that class of 0. Okay, because class of 2, what is class of 2? Class of 2 again, if it is a collection of all those set A elements. Set A is here integer, x belong to z, so that x related to 2. Okay, what is the meaning? X belong to z, x minus 2 divisible by 2. Okay, x belong to z, x minus 2 divided by, it means that x minus 2 is of the form 2k where k belong to integer. Okay, or x belongs to z, x belong to z, and x minus x equal to 2k plus 2. What we have? X equal to 2k plus 2, k belong to integer. And here what we have? X belong to z, x 2 common, k plus 1, and k belongs to integer. And here we can replace k plus 1 by some other integer. So x format will be actually 2k n new. Okay, and this kn belongs to integer. Hence it is of the form, again the format of this one is similar to that the format of this one or not. See, so that's why if we divisible by, if the question is divisible by 2, then it have only two equivalence classes, class of 0 and class of 1, different equivalence classes. Okay, and if they are asking about the suppose in place of divisible by 2 it is given divisible by 3, then we have three equivalence classes. And if it is there that a minus b divisible by 5, then we have five equivalence classes, class of 0, 1, 2, 3, 4, 5. It may ask in MCQ or guarantee. If the question come in 5 marks of relation function, then they may ask guarantee that what is the equivalence class of particular element. Okay, so you need to do like that. Okay, I hope you understand. Now next one, next question, this one. Yeah, here we have the question is 2 sine inverse x equal to the sine inverse 2x square root of 1 minus x square holds good for which? They are asking holds good for which one of them. Okay, so observe that 2 sine inverse x equal to the, here it is given. Okay, so okay, actually we need to find for which x it is true. Okay, okay, the range of sine inverse 2x square root of 1 minus x square is minus pi by 2 to pi by 2. This thing we know already. Okay, if the range of sine inverse 2x square root of 1 minus x square is minus pi by 2 pi by 2, okay, so what it implies, it means that sine inverse 2x, or we can say if this range is in between, okay, we can say that like that, 2 sine inverse x is also have the same range, because LHS is equal to RHS. As we know na, recall this thing, recall sine inverse x range has to be in between minus pi by 2 pi by 2. That's why I'm saying this thing. Okay, so outer function is sine inverse na, so the range has to be in between, the complete range has to be in between minus pi by 2 pi by 2, and side part is in between minus 1 to 1. Okay, so it means that 2 sine inverse x is in between minus pi by 2 to pi by 2. Now we can divide by 2, so minus pi by 4 pi by 4. Now we can take sine both side, whole side, sine of minus pi by 4 x sine of pi by 4. Okay, so sine of minus pi by 4 minus 1 upon root 2 x, and here 1 upon root 2. It means that, what is the meaning of that? It means that the mod x value is less than or equal to 1 by root 2. Okay, so here the option is, which option is true? This one option is true, C option. You can see here, C option is mod x less than equal to 1 upon root 2. Okay, now the next question is this one. They ask what is the, write the value of this one complete. Okay, so first of all we will find the value of cos inverse 1 upon 2. Okay, first of all we need to find the value of cos inverse 1 upon 2. How we can find the cos inverse 1 upon 2 value? See, cos inverse 1 upon 2, the value will be cos of pi by 3. Okay, so it will be pi by 3. Okay, this is first. Second thing is sine inverse minus 1 by 2 they give. What they give? Sine inverse 1 minus 1 by 2. Okay. So it is minus sine inverse 1 by 2. Okay. Minus sine inverse 1 by 2. So sine inverse sine of pi by 6. So it will be minus pi by 6. Okay. Understand? Now I will put both the values, this one value in that equation, and what we get, see here, cos inverse 1 by 2 value is pi by 3 minus 2 times minus of pi by 6. Okay, so here you can write the reason, sine inverse minus of theta equal to minus of sine inverse theta. Okay, this thing you need to understand. Okay, so here we have minus plus pi by 3 plus pi by 3, 2 pi by 3 we get. Okay, now the next thing, it may possible, listen, we can generalize this question also. Here you can possible, here may be possible that they give tan inverse here, so value may be changed, value they can change, but they can ask in sine inverse, tan inverse, cos inverse. Okay, negative value. So so what you need to learn from this question, that sine inverse of minus theta, cos inverse of minus theta, tan inverse of minus theta, cot inverse of minus theta, okay, sec inverse of minus theta, and cosec inverse of minus theta. All these things you need to know. Okay, all these, understand? Okay, now listen, next question we have, yeah, the next question. Next question is x plus 1 upon x, they give x plus 1 upon x equal to x square plus 1 upon x square, where x is non-zero. Okay, and they ask what is f of x actually, what is f of x. So what you need to do here, let, if this type of question will come, then x plus 1 upon x we can assume t. Okay, and squaring both sides because we want this value. Okay, if here I am changing the complete x variable into the variable t, and then I will use the transformation. Okay, but first I will transform. So if this I'll assume t, then what is the value of this one function? Squaring both sides, x square plus 1 upon x square plus 2 equal to t square. So t square minus 2 x square plus 1 upon x square. It means the complete quotient is transformed into f of t equal to t square minus 2, and hence the f of x is x square minus 2. Okay, and the answer is this one. Okay, I hope you understand. Now the next one is, yeah, this one. Let's start. Check whether relation R in the set Z, it means set A is, immediately you can write set Z we have. Okay, and we have a relation R. How they define relation R? A comma B, it is a collection of all those ordered pair such that A plus B divisible by 2. A plus b divisible by 2. Okay, so let's start our solution. First of all, we need to check is it reflexive, symmetric and transitive, and then finding the class equation. Okay, equivalence class of 0. Okay, guarantee they will ask this question in the 5 marks. Okay, 5 marks they will ask this question. Okay, because they are asking, first of all we need to have 3 things: reflexive, symmetric and transitive, and then also we need to find the equivalence class of the element 0. That's why. So for reflexive, okay, what do we need to for reflexive? Let A belongs to A, where A is Z. Okay, if A is an integer, observe A plus A, that is 2A, is divisible by 2. Okay, it is divisible by 2 clearly. So it implies that A comma A belongs to relation R. It implies that A related to A. So from first and from second, both the first and second implies that each element of A related to itself. So it implies that R is reflexive on A. R is reflexive on A. Now we need to check for symmetric. For symmetric, what we need to check? We need thumb rule is we need to choose 2 element of set A, and one more condition we need to assume A related to B. Okay. Now, if A related to B, what is the meaning? It means that A plus B, wait, A plus B divisible by 2. If A plus B divisible by 2, it implies that A plus B equals to 2k, where k belongs to Z. Okay. So if A plus B equal to 2k, B plus A is also 2k, because addition is commutative. K same, k is already belong to them. Okay. So it implies that B comma A belongs to relation R, and it implies that B element related to A. Okay. It means that whenever A comma B belongs to R, ordered pair A comma B belongs to R, then it implies that B comma is also belongs to R, that is B related to A. Okay. So it implies that R is symmetric on A. R is symmetric on A. Now, for transitive, for transitive, same thumb rule is we need to assume 3 elements: A comma B and C belong to set A. Okay, and one more, 2 things we need to assume more: A comma B belongs to relation R, and B comma C also belongs to relation R. Okay, if A comma B belongs to R, what it implies? A plus B 2k1, A plus B divided by 2, and it implies B plus C equals to 2k2, and here k1 and k2 belongs to Z. Okay, now we need to check is A plus C is also 2k type or not. Okay, so what we can do, we can add both of them. Okay, if we add both of them, A plus B plus C equals to 2k1 plus 2k2. Okay, now what we get from here, A plus 2b plus C equals to 2 times k1 plus k2, k1 plus k2. Okay, Moreover, we need to prove a plus c is 2 times of some integer. So what we need to do, we can take this b to the left side, b, okay, because b is also an integer, a na, a is also integer set. So 2 times we can take k1 plus k2 minus b, a plus c, and this thing we need to assume like that, okay, and k belongs to integer a, because sum of integer is again integer, that's why I'm saying, okay. So a plus c is 2k times and k belongs to integer, it means a plus c divisible by 2. If it is divided by 2, it means that a related to c, and if a related to c, it implies r is transitive on a, okay. Now what we need to find here, actually, we need to find, I think, equivalence class of 0, okay. So equivalence class of 0 we need to find, yeah, here, class of 0, that's a b part, okay. Class of 0 is the collection of all those elements of a which are related to 0, okay. It means that x belongs to a such that x plus 0 divisible by 2. It implies that x belongs to a such that x alone, here x alone divisible by 2. So clearly it is the type of 2k where k belongs to integer, class of 0, or not, it is the collection of all the even integers. It may possible they will ask class of 1, what will be, okay, then class of 1 is the, from here, collection of all odd integers, okay, and only two classes are there, class of 0 and class of 1. If the class of 2 they ask, then it is same as that the class of 0, class of 4 class same as that class of 0, class of 6 same as that class of 0, okay. I hope you understand this question. Now next question is, yeah, next question they are asking the function um, the function x square bx plus c, okay. Yeah, listen here, question is f of x equals to x square plus bx, x square plus bx plus c, where b comma c are real constant, describe, okay. It is 1 1 mapping, onto mapping, not 1 1 but onto, neither 1 1 nor onto, we need to check, okay. So observe that this function is x square plus bx plus c, okay. So it is a quadratic polynomial. If it is a quadratic polynomial, then guarantee the graph of this function is like that of the parabola, or not, like a graph of x square, okay. So and the domain of this function is complete R, domain for this function is complete R, okay. So function is defined from R to R, we can take, okay. And the graph of this function is like, here c is a real constant, so c may be 0, so in further I'll took c is any number, okay. I'll took c is positive, okay, without loss of generality, so c is positive. So maybe parabola is like that, maybe like that, okay, maybe like that, okay, or it may be like that if c is negative, but guarantee the parabola is upward parabola. Why so? Because the leading coefficient is positive here, that's why the parabola is upward parabola, okay. So you can observe that let us hypothetically I'll assume that our parabola is like that. Okay, hypothetically I assume. Okay, so clearly you can observe that guaranteed has a minimum value and there is no maximum value. Okay, guaranteed has minimum value but there is no maximum value. Okay, now so for negative, for negative, here I am saying that guarantee there are integers, precisely negative integers are not in the range. Not integer, negative real numbers. Negative real numbers. Negative real numbers are not in the range. Okay, negative real number are not in the range, so it implies that range of f not equal to complete R. So it implies if range is not equal to the codomain, f is not onto. Okay, and also you can observe that this thing, I'll draw like that. For this element we have image here alpha 1, for this element we have image delta 2 here. So this alpha 1, f of alpha 1, suppose this length is beta. Okay, so f of alpha 1 is also beta and alpha of alpha 2 is also beta. So two different elements have same image, it means f is not 1 1. And guarantee we always know, already know this thing, that whenever we have a parabola, then guarantee that function is not 1 1 function. Okay, so neither 1 1 nor 1 2 is the answer of this function. Okay, if we have another function with the power even, then also guarantee we can say the function is not a 1 1 function. Okay, and also the range is depend on the, and also, but here you can observe that domain is not defined. So domain we need to define by ourselves. See here they did not give any domain. So if such condition will appear, then what we need to do, we need to define the domain by ourselves. We need to find the domain of this function by ourselves. How? The largest subset of R on which this function is defined. The largest subset of R on which this function is defined, we need to take that set. Okay, here that set is complete R, and codomain you can take complete R. Okay, if they are not giving. Now next one is, now next question is, what we have next question. Okay, next question, this one. See here. Yeah, how we can approach? Here they are giving x is, mod of x is less than equal to 1. If they are giving mod of x is less than equal to 1, it means that x is to be in between -1 to 1. Okay, okay. Now for option A, they are asking that which one of the four is different. They are asking which of the following four is different from the other three. It means the three are of the same category and the fourth one is different. Okay, so for A I am going for A, sine of cos inverse x they are giving. Okay, so let cos inverse x I will assume y. So cos inverse x is y, then cos of y is x. So this is y, wait, this is x, this is 1, then this is square root of 1 minus x square. Okay, so as it is sine of y, as I assume, so sine of y value is square root of 1 minus x square. So here you can observe that it will match with the option A. Option C also. Option C. So it implies that option A and option C are same. Okay, now I'll check B from B. For B, what is B given? Cos of sine inverse x. Okay, cos of sine inverse x, and again same thing I need to assume. Sin x, sine inverse x equal to y. So sin y equal to x, y x upon 1 square root of 1 minus x square, and again we observe that cos of y value is square root of 1 minus x square base upon hypotenuse. Hypotenuse is 1. Okay, that's why. So it implies that option A, B, option A, B and C are same. Okay, option A, B and C are same. So the which option is different? D option is different. That is the answer. Because they are asking which one is the different. Okay. Now, next question is the relation R is given like that. Okay, where is a prime number less than B, less than 5. Then they are asking range. Okay, so they are asking the range of this relation. How we can find the range? First of all, they are asking here A is a prime number less than 5. So how many prime number less than 5 is 2 and 3. A values 2 and 3. So we can put 2 with 2 raised to power 3, 3 comma 3 raised to power 3. Okay, so 2 comma 8 and 3 comma 27. What we get? 2 comma 8 and 3 comma 27. So the range of R is 8 comma 27. Range of R is 8 comma 27. I hope you understand this question. Okay, now the next question is, they may give here different relation and we need to find the same thing. Okay, now see here. Next question we have, let function R to R define f of x equal to x to the power 4. The correct option is, which one we are asking? Okay, clearly this function is even function. This function is even function. Even function, an odd function is f of minus x is f of x for all x, then f is even function, and f of minus x is minus fx for all x, then f is odd function. Okay, now one is even function, and also the power function is defined from the set R to a set R, and also f of x is x to the power 4. What we have? X is to the power 4. So the graph of this function on this complete R is like that. Okay, so clearly this function is not 1 1, because for two elements with a different position, alpha 1 and alpha 2 maps to the same element beta, if this length is beta. Okay, so f is not 1 1. If I want to give counter example, f of minus 1 is 1 and f of 1 is 1. This is a counter example you can take. But horizontal line test also you can tell that we can see clearly that it has for two different elements same image. So different element does not have different image, so function is not 1 1. If function is not 1 1, then this option is wrong and this option is wrong. Okay, this now if this function is onto, observe that here the power is x to the power 4. Okay, so whatever input we are giving here, the range is greater than equal to 0. The value output set is greater than equal to output elements, every output is greater than equal to 0. It means that but the codomain of this function contain the negative element also. If the codomain of this function contain negative element also, then those negative elements are not in the range. If those elements are not in the range, it means that the function is not f of x is not onto. Okay, because negative element negative element are not in the range. Hence, this option is wrong. Only D option is correct. Okay. Now the next question. They are giving. Next question, show that the function R2 are defined f of x equal to here, and we need to prove this is 1 1 and onto function. Clearly, how we can prove 1 1 function? See, it may possible here linear upon linear may become. Okay, so the procedure is same in every question. How? Let x1 comma x2 belongs to the real number here with what we need to assume for 1 1 I am saying this thing. Okay, for 1 1 question with f of x1 equal to f of x2. We need to check is x1 equal to x2 or not. Okay, f of x1 definition apply, 2x1 minus 1 upon 3 and 2x2 minus 1 upon 3. Okay, 3 cancel, 2x1 2x2 x1 equal to x2. Yeah, this function is 1 1 function. Okay, now for onto we need to check for onto. What we need to assume? Let y belongs to R. Any element we need to choose from the codomain set. Y belongs to R and f of x equal to y. Okay, f of x equal to y here. Now f of x value is 2x minus 1 upon 3 equal to y. So find the value of x in terms of y. Find the value of x in terms of y. How we can find? 3y, 2x, 3y plus 1, 3y plus 1, and x value is here 3y plus 1 upon 2. This is your x. So it means, and there is no restriction of y here, so it means for every y belongs to R, we have a x. It means whatever y you choose from the set of real number, we have its pre-image, that is 3y plus 1 upon 2. It implies that f is onto. Okay, so it means from the first and second, from first and from second, f is bijective. Okay, f is bijective here. But listen one more thing. Here they are actually asking only 1 1 and onto, but it may possible they will ask that if function is 1 1 and onto, as we know their inverse is also exist. Their inverse is exist, that means the function is invertible if the function is 1 1 and onto. Okay, so here I am adding one more additional question, that find f inverse. Okay, so what is the procedure to finding the f inverse for a given function? Actually function is f of x equal to 2x minus 1 upon y. 2x minus 1 upon, check, 2x minus 1 upon 3. Wait, 2x minus 1 upon 3. Okay, so what we need to do? Let fx equal to y first thing. So 2x minus 1 upon 3 equal to y. Its procedure is same as that the procedure of to finding one onto function, to proving onto function. Okay, so here what you need to do? Value of x in terms of y. Value of x in terms of y. Second step. So value of x in terms of y, from above step we can copy 3 plus 1 upon 2. Okay, now sweep the things. Replace x by f inverse x and y by x. So what we get? F inverse x equal to the 3x plus 1 upon 2. Okay, this is the inverse of that function. Like that we can find. Don't write these things. These things you need to keep in mind. Okay, just you need to follow the steps and directly write this thing. After reaching to this step, you can move on this step. Okay, No need to write, just keep in mind this thing. Just you need to keep in mind this thing. That's why I'm writing. Okay. First step, f of x equal to y, then this thing, and then value of x in terms of y, and then sweep these things. Okay. Now, here I think there is the same question which we already completed, that the show that the relation R on the set Z of all integer. This is your homework. You need to do by yourself. Okay. And here show that the relation R on the set of integer, that means A is a integer. What is A here? I will write given here, set of integer Z. Okay. And the relation R is, how the relation R is defined? It is the collection of all those ordered pairs such that x minus y divisible by 3. Okay, that is we have, and clearly it is an equivalent solution. I already proved. Okay, it may possible they will ask here that how many equivalence classes are here. So equivalence classes are 3 equivalence classes are possible, as divisible by 3, so 3 equivalence classes are possible. 3 equivalence classes, okay, for given relation on A equal to Z. Okay, and that will be the class of 0, class of 1, class of 2, and class of 3 is same as that a class of 0. Okay, like that you can find. You need to do by yourself. I gave you hint here. Okay, you can do. If you have any problem, you can do comments. I will reply there. Now I think everything complete. Okay, some things are there. Okay, this question I already discussed in the question series of NCERT mathematics. Okay, there you can see. Okay, exercise, this is exercise 1.1, question number 16, last question. Okay, and just you need to check directly that which one is the correct option. Okay, so I will do. Okay, no problem. A option is immediately wrong, because here B, they asked B value is greater than 6, but B is less than 6. That's why we will not, this 2 comma 4 does not belongs to R. Okay, because here they are saying that B has to be greater than 6. Okay, condition is there, B is greater than 6. Okay, now B option we can check. 3 equals to 8 minus 2, that is 6 equal to 3. Not possible. Okay, this is not possible. C, 6 equal to 8 minus 2, yeah, it is possible. Okay, so option is C is there. Proper explanation I gave there. Okay, you can see, but simply you can put the value and get the value and get the answer. Okay, here also it is not true. 2 4 minus 2 2, but we can't apply this condition. We can't check this condition, because why so? Because this thing is not true. Okay, this thing is not true. First of all, we need that B is greater than 6. So this option is directly wrong. B, C, D we need to check. Satisfy or not satisfy. Okay, now next question what we have. Okay, the next question is what is the next question here? Okay, cos inverse alpha and cos inverse beta, cos inverse gamma, 3 pi. We have this thing. Okay, so here the answer what we have, cos inverse alpha equals to pi, cos inverse beta equals to pi also, and cos inverse gamma is also pi. Here they are saying cos inverse alpha plus cos inverse beta plus cos inverse gamma equal to 3 pi. Okay, and they are asking find the value of this one. So we need to find the value of alpha and beta gamma. Okay, so here cos inverse alpha is pi, because the maximum value of the cos inverse this function is, as we know that for function cos inverse x, domain is, that is -1 to 1. Okay, and the principal value branch, that is range, is 0 to pi. So the maximum value is pi. It means if the sum of these 3 numbers, first number, second number, and third number is 3 pi, then it means its maximum value has to be pi. That's why I am saying. So alpha value -1, beta value also -1, and gamma value also -1. Why so? Because cos of pi is -1. We can take cos both side. Okay, so alpha beta gamma equals to -1 here. If alpha beta gamma equals to -1, we can put here what will be minus 1, minus 1 minus 1 plus 1 minus 1 minus 1 minus 1 minus 1 minus 1. Okay, and at the end what we get, if you are solving you get 2 value here. Okay, I hope you understand this thing. You understand or not this thing? Because cos inverse alpha plus cos inverse beta plus cos inverse gamma equal to 3 pi, okay, they are giving. So when it is possible, that when this function has separate value pi, this function has separate value pi, this function has separate value pi, because if suppose this function is not giving complete value pi, then it means one of the and any one of them from cos inverse beta and cos inverse gamma give value greater than pi, which is not possible, because for the cos inverse x we have this thing, domain is this one and range for this function is this one. Okay, so range is 0 close 0 to pi, it means maximum value is pi, so that's why these things. Okay, I hope you understand. Move on to the next one. Okay, this one is easy, this one I think you can do easily. Okay, first of all we need to find the value of inside. Okay, we can write like that, tan inverse 2 sine, actually what we can do, we can find the value of inside function. Okay, otherwise we need to do many steps. Okay, without any reason, cos inverse root 3 by 2. Okay, so cos inverse root 3 by 2, its value is cos of pi by 6. Okay, so its value is pi by 6. Okay, the value of this function is pi by 6. The value of this function is pi by 6. Okay, and if you multiply by 2, what we get? Pi by 3. Okay, then sine pi by 3 value is, what is sine pi by 3 value? Sine pi by 3 value is 1 by 2. Okay, wait, sine pi by 3 value is 1 by 2. 1 minute. Okay, here we come back, sorry for the interruption. Okay,